And as far as getting the critical values, we would set that equal to 0. Okay. But let's also get pi 2. Pi 2 would just be P20 minus Q1 minus 4Q2. So you set that equal to 0. Notice when you solve for the critical values of Q1 and Q2 will be expressed as functions of P1 and P2. Okay, so there'll be general solutions. There won't be numerical values, but there'll be solutions in terms of P1 and P2. Pi 1, 1 then is what? -4. Notice again, it's always -4 for all values of Q1 and Q2. Just a constant function. Pi 2, 2 is? Yep. Pi 1, 2? Pi 1, 2 would just be -1. So this is negative everywhere. That's negative everywhere. So this is a pi 2, 2, excuse me. And pi 1, 1 times pi 2, 2 is always 16, which is greater than pi 1, 2 squared, which is 1. Therefore, this second order total differential is negative definite everywhere. Therefore, this is what kind of a profit function? Say it. The profit function is? Okay. Yeah, it's actually strictly concave because this is always negative definite. So our profit function in this case is strictly concave. So if you satisfy these first order conditions, then you get the maximum profit. Okay. Let's look at these. Let's go ahead and solve these first order conditions. I see we still have some time left. So let's go ahead and solve those. If I rewrite those first order conditions for Q1 plus Q2 equals P10, and then the second one I write as Q1 plus 4Q2 equals P20. We could just use Cramer's rule again to solve for Q1 and Q2. And since we know that our objective function is strictly concave, these will be the values of Q1 and Q2 that generate the absolute maximum profit. Okay. So using Cramer's rule, Q1 star, the optimal value for Q1, would just be this. Take the determinant of the coefficient matrix in the denominator. That would be 4, 1, 1, 4. And in the numerator, we substitute P10, P20 for the first column. And then it's a 1, 4. So what do we get here? 16 minus 1 is 15, the denominator. In the numerator, it's 4 P10 minus P20. Okay. So if I give you values for P10 and P20, you just plug in and you get the value of Q1 star. Okay, but this is more general. Our value for Q2 star would be as follows. Again, this is going to be a 15 down here. Up here, it would be 4, 1, P10, P20. So we would get 4 P20 minus P10, all over 15. Okay, that would be our optimal value for Q2. That would give us the absolute maximum profit. Notice one more thing we could do. We could do some comparative static analysis. What is partial Q1 star, partial P10? Here's your expression for Q1 star. So what would this partial derivative be? 4 over 15. Just the coefficient on P1 star. Notice this is positive. So what does this mean in words? Right. Right. And that makes sense if you think about it, because if the price of product 1 rises, you're going to want to produce more of product 1. So that makes sense, doesn't it? Okay. Because our profit, what was our profit function? Did I erase it? Tell me what our profit function was. Yeah. Okay. Thank you. Okay. So, what is P10 in economic terminology? It's the price of product 1, but it's also what?
Cost.
Not the cost, but marginal. It's a marginal revenue. For every extra unit of product 1 you produce, you generate this much extra revenue. So it kind of makes sense if the marginal revenue of producing product 1 rises, that you're going to want to produce more of product 1. Okay. Let's do this derivative. What is partial Q1 star, partial P2? Negative 1 over 15. That's negative. So where is this coming from intuitively? Why is the price of product 2, why is that goes up? You want to produce less of product 1.
You want to shift your resources to producing product 2.
Right, you want to produce more product 2. And notice what our cost function was. Let's look at our cost function. It's 2Q1 squared plus Q1 Q2 plus 2Q2 squared. So if you look at the marginal cost of producing a product 1, C1, which is just partial C, partial Q1. This marginal cost is just 4Q1 plus Q2. In other words, the marginal cost of producing product 1 rises with more of product 2 produced. So the more of product 2 you produce, the higher the marginal cost of producing product 1. And intuitively, that's why this thing is negative. Okay. Let's look at the others. They make sense too. What about partial Q2 star partial P1? What is this partial derivative equal to? Anybody? Negative 1 over 15. It's negative. So this makes sense. As the price of product 1 rises, then the marginal cost of producing product 2 goes up. If you look at the marginal cost of producing product 2, partial C, partial Q2, or just C2. That is going to be Q1 plus 4Q2. So the more of product 1 you produce, the higher the marginal cost of producing product 2. So as the price of product 1 rises, you want to produce more product 1, but that raises the marginal cost of producing product 2. So that's why this turns out to be negative. And then finally, partial Q2 star, partial P2 is just 4 over 15. And it makes sense that that would be positive because P2 is just the marginal revenue for producing product 2. Marginal revenue producing product 2 goes up. You want to produce more product 2. But less of product 1 because of this cost function, because of this term right here. Okay. So you could also do comparative static analysis in this problem. Okay. Well, I think we've gone long enough for today. I apologize for that mistake on the syllabus. We'll perhaps make it up by going a little bit longer in our 641 classes. Okay. All right, that's all for today. And thanks again, Ian, for the water. It did help.